Hi, I'm Daryl, a tutor with Chegg Tutors, and my topic to explain today is electromotive force, or EMF. So, electric motive force is the voltage, or in other words, the potential difference produced by a source of electrical energy. Now, if you're dealing with a circuit and calculating values or solving the circuit, you've got battery and series with resistor, and you want to know how much current's flowing through this resistor based on the EMF produced by the battery. Then you can just treat electromotive force as voltage. You measure it in volts, you can plug it in for the appropriate V in your equations. Any lesson on voltage will give you more detail on that. Something like Ohm's law or Kirchhoff's voltage laws cover the details for solving simple circuit equations with resistors and batteries and so on. For this lesson, I want to talk instead about electromotive force as a result of energy being transformed from one form to another. Specifically, from the forms of chemical, magnetic, and electromagnetic, as in light, energy, to electrical energy. Any source of an electromotive force is analogous to a pump, taking one form of energy and using it to push charges through a circuit. These are three of the most common examples we'll work with here. So, concerning chemical sources of electromotive force, these are generally batteries. AAA batteries, car batteries, they're all electrochemical cells. The chemical reactions that occur within them create positive and negative charges at the plus and minus ends of the cells. This process continues until the buildup of separated charge within the battery opposes more reaction, or, if it's connected into a circuit, when the chemistry of the electrolyte is depleted, after pushing charges from one side of the battery through the circuit to the other side. It's the tendency for whatever the electrolyte is to react that pushes the electrons or charges through the circuit. And that's the source of the electromotive force, is the chemical potential inside the battery. On magnetic sources of electromotive force, you have electromagnetic induction. What's happening here? On magnetic sources of electromotive force, then the principle of electromagnetic induction is the process by which a changing magnetic field produces an electromotive force within conductors nearby. The more change in the field the conductor experiences, whether by the movement of the conductor, or the movement of the magnet, or a change in the strength of the field, then the more EMF is produced from one end of the conductor to the other. This is the principle that drives generators. Generators do some form of work to spin a magnet or spin coils of wire in a magnetic field, and through that produces a current. It can also power generally within these devices, generators and other electromagnetic inductive devices like transformers, you'll have coils of wire. The coil allows each loop of the wire to experience the same changing magnetic force in order. Each coil of the wire experiences the change in magnetic flux, which causes the EMF. So where one loop of wire would experience a certain amount of EMF, 10 loops of wire will experience 10 times the EMF. And so you'll have loops with hundreds of turns of wire inside these generators or motors or transformers or any other electromagnetic inductive devices in order to multiply the effect of the motion. So this is a not unlikely setup. You would have a rotating magnet inside a set of coils. You could also have the reverse situation, which is also common, rotating coils inside a set of permanent magnets. Either one produces a similar effect, which is a changing magnetic field experienced by a conductor, which creates an EMF. Now, onto light-induced EMF, in the sense of photovoltaic cells, or solar cells. In a photovoltaic cell, an EMF is generated when the cell is exposed to light. The material of the cell is, through its thickness, designed to have a built-in energy gradient for electrons. So one side of the cell is up at a higher potential energy, the other side of the cell is down at a lower potential energy as far as electrons are concerned. And there's a gap between the two levels of energy that are available within the material. Under illumination, or when the material is struck by photons of sufficient energy, an electron may absorb a photon, jumping up to a higher energy level where it is free to move down the gradient to the other side of the cell. This movement to one side of the cell or the other is what causes the charge separation that powers an electromotive force. By moving electrons up and over to one side, they produce the positive and negative end and the voltage that drives power through a circuit. So what you would see here, this is a diagram of the energy levels inside the material. A photon would enter the material where the electrons are down at this lower level. An electron absorbs the photon, and with that energy moves up to the higher energy level across the gap. Now in this higher energy level, the electron is free to move, and it rolls effectively downhill in terms of energy towards what would be the negative side of the cell, where the negative charges accumulate. And it's this physical charge separation that powers the electromotive force produced by the cell. And now you took up several of these cells in series, or have a big wide panel of them, and that's where you generate your solar power. And It's all converting energy from one form into another, specifically into the separation of electrical charges.